So, for the last year and a half, I've been working on a game about building a new settlement. The core system for this game is about inviting people over to live and work in your new settlement. From Sundermead's inception, this mechanic was done through what's called the Summoning Stone, which is an item that the player uses to interact with the gods. They do this to talk with them or make sacrifices to them. One of these sacrifices allowed you to invite your first villager to Sundermead. This would be done by sacrificing 50 wood, and then Woden, the king of the gods, would go out and look for your first villager. After 3 days, he'd send this man here, Farman, who's a shipwright, and through him you'd get quests and then the next character, and then through that character you'd get the next, and so on and so on. The problem with this system was that the Summoning Stone was also used for lots of other things, such as requesting rain, or food, or seeds, and plenty of other things as well. This meant that the character inviting system took a bit of a back seat and made the game almost feel like a survival game, which it really is not. Because the plan was always for it to be a Stardew Valley-esque game with Minecraft elements, but it ended up being the other way around. And having a game present itself the wrong way is a recipe for disaster because players just won't know what they're going to get. This needed sorting out as soon as possible. And I realised that the core of this problem was the Summoning Stone, because not only did it let you do lots of things, but it was also extremely clunky to use. To replace it and make the character inviting system front and centre, I've decided to add a new ledger item. At first, I planned on making it so when you started a new world, it was a physical item in the world and you'd have to place it down before you could do anything else. And that location that you placed it at would then be the centre of your village. But I realised that making players make such a drastic decision at the beginning of a game might not be such a good idea, and it might even put them off from playing the rest of the game. After some thought, I settled on the ledger item, which instead of it being something you place in the world, it's just a normal item that you'd have in your inventory, like a food item, except that you can interact with it. It behaves similar to your tools in the inventory in that you can't sell it, but you can place it in chests and containers. I then decided that I wanted this ledger item to behave similar to a tech tree, where there would be a tree visible to you, and unlocking one thing would unlock the next, and that 2 more, and so on and so on. The rendering of this tree was actually the most difficult part of this whole system, because I wanted a way to be able to procedurally draw this tree, regardless of any changes I made to the back end of the system. And so the positions of each of these tech tree nodes, or character nodes, needed to be procedural, and also be able to sort themselves out if I decided to change anything later on down the line. So I went down this huge rabbit hole in trying to find tree rendering algorithms, and I eventually settled on the Tilford-Reingold algorithm, devised by these 2 absolute studs. And here's the final result. I've got to say, I am extremely happy with how it came out. Next, I just needed to set up conditions for inviting these characters. To do this, I just used Unity scriptable objects, which allow me to drag and drop these items into my little graph. Each character has 2 default conditions, the first being whether the previous character was unlocked, and the second being whether there is a bed free. But after that it can be anything I want really, from time of the month to whether a quest is completed and so on. There are also scenarios like with the shipwright when a character's bed needs to have certain conditions, for example be near water. I was able to do this using virtually the exact same system. So you can see each of those conditions here on the character panel. Any unmet conditions will display in red and any met conditions will display in green. For my next task, I thought I'd let myself off and do something a little bit easier, so I decided to go for the ladder. The idea is that it works similar to Minecraft, where you have a ladder item in the world and it can just stack on top of each other as far as you want to go. And using my entity and item system that I've had since the beginning, it was super easy to do. I just needed to make a few adjustments to let the ladders stick to the walls. And then I got some animations in and voila, ladders! Alright, so I thought it was about time to talk about how my AI works. In the past, I've briefly spoken about my AI packages system, which is inspired by how Bethesda do their AI. It's actually a free Unity package, and the link to it is in the description. But beyond that brief mention, I'd never really spoken about how the AI see and interact with the world. So firstly, how does my package system work? Well, an AI actor, as I call it, has a list of packages, and those packages are prioritized by the order that that list is in. For every tick, not frame, because there's a whole timing system I've made for the AI as well, the AI will go through each of these packages until it finds one whose condition is met. And this is why the priority order is so important. And some packages also have completion conditions, meaning that they won't be able to go on to the next package until the current one is complete. Anyway, once a new package is found, it will initialize it with the onStart method and then it will begin to tick. And this is where things start to get interesting. This is because each package actually has a separate behavior tree inside of it. And this is done using another free Unity package called Fluid Trees. Not made by me, because I wouldn't have a clue how to do it. And so each time the package ticks, the behavior tree ticks as well. So before I made my package system, each actor had one massive behavior tree, but I found this so difficult to maintain and extend, which is the reason I made this package system, just to make it as modular and maintainable and extensible as possible, which is of course all the things that programmers love. And now that the actors can execute behavior, they need a way of interacting with things in the world. This is done using my actor interactor component, which is kind of strange to say. So I can simply drag this component onto any object, define a few positions that the actor will interact with that component at, and then I can define some behavior that the actor will do once it's interacting with that component, such as playing an animation. Well, the next question is, how do these actors find these interactable objects in the world? Well, luckily Unity has a built-in function called physics.overlapSphere, which is just a way of querying the physics system based upon position, radius, and layer. And luckily my interaction component will automatically set its positions to said layer. So this means when I run this query, I can make it only look for the actor interaction layer, saving a ton on performance. And here are a few examples of this system working. Notice how the amphel has two positions that the actor can interact with, yet triada only ever goes to the one that isn't blocked. This is because when an actor first interacts with an interactable, it asks the object for any positions that aren't obstructed or blocked off. This way, actors will only ever interact with an object in a way that makes physical sense. Well, I reckon that's about the gist of it, so if you like the look of my game, I have a Steam page where you can go and wishlist it, and a Discord where you can come and chat about the game or even keep up to date with more granular updates. As well as those two, I've also got a Patreon now, with the highest two tiers giving you early access to the game so you can test it and help me make the best product it can be. With all that said, thank you very much for watching. It'd be much appreciated if you could leave a like and a subscribe for the algorithm, and I hope to see you in the next video. If you want to, you... What? If you want to, you it. What?